Good morning, everyone. This is Dr. Mama Gazal. Today in this video, we will talk about thermodynamics, state functions, and path functions. State functions and path functions are very important parameters when we are talking about thermodynamics because these functions will give you an idea that how many parameters we are having and from which a particular approach you are going to analyze your own system. So that's why these are very much important in thermodynamics. So here we will talk about one by one state and path functions today. So state functions, and to understand better the state functions and path functions, it's very important to discuss about the changes which occurs in a system. So it is necessary to define its properties accurately before and after the change has been occurred in a system. That's why it is done and is specifying the state of the system, which means that the temperature, pressure, and composition of a system are specified in such a way that all other properties of the system are automatically fixed. When we are talking about a thermodynamic system, it is said to be a definite state when each of its properties has been fixed. So here also it is written that the state of a system is determined with the help of some measurable quantities like volume, temperature, density, pressure, etc. And the quantities which can identify the state of a function are said to be properties, and state and path functions both are thermodynamic terms which are used to name these particular properties. Here you can see this picture that where I'm demonstrating about the state function properties because their value do not rely on path. Temperature, pressure, energy, volume, mass. When we are talking about these particular variables or parameters, how we are defining, because we are not concerned how the temperature reaches from the initial to the final state with acquiring which path. We are concerned about the initial state of the temperature, what will be the initial temperature and what will be the final temperature. So that's why pressure, temperature, volume, mass, energy, these are said to be the compositions of the fundamental properties of a system, which specify the state of a thermodynamic system. If any change in the value of these properties brings in the state of a system, then these quantities are said to be state functions or thermodynamic variables or state variables. So first we will talk about specifically about state functions in thermodynamics. A thermodynamic property that depends only on the initial and the final state and does not depend on the path taken to reach to the final state or value is known as state function or point function. When we are talking about the properties which are totally depend on state includes pressure, temperature, and amount of substance. So at that time, for example, if we are taking an example of a density, which is a state function, it does not depend how a substance is obtained. Similarly, other thermodynamic properties which will give you an idea about state functions are said to be internal energy, enthalpy, entropy, Gibbs free energy. These are the various state functions and those state functions which are totally depend on the initial and final state. Variables which depend only on the state of the system are said to be state functions, and state functions determine only the physical state of a given system. In a particular state, the value of a state function do not depend on the previous history of the sample. So here from this picture, you can see that this is said to be the initial point from where means from the bottom of from the bottom, and this is the top of the mountain. This is said to be the final destination or the final state. So to acquire from the initial to the final state, which path we are taking, it does not bothered about. We are not bothered about those one. Why? Because we are talking about initial and the final state. So this will give you an idea about the state functions and which path you are acquiring, that is said to be the path functions, which parameters are come under consideration when we are talking about path. So these are the two different paths by two different lines, red and blue. So we can acquire any of the path to reach to the final destination. So this is the difference between the state function and the path functions. Now we are going to talk exclusively about path functions in thermodynamics. So when we are talking about path functions, it depends on how a change takes in place in a system. For example, if you're taking an amount of work done in a chemical process and that depends on how the change has taken place, then it is said to be a path function. And a thermodynamic property that depends on the path between the initial and the final state, that is said to be the path function. Here you can see from this picture that this is my initial point from the start and I have to reach to my end final destination. So these are my two states, initial state and final state. To reach to these positions, I can acquire any of the path like path 1 which is going straight, another path which is going in this way. So these are the two possibilities to reach to my final state by acquiring any of the path. So that's why the path functions depend on the path taking or covered between two initial states. So in this way, we are having an idea about the path functions, and here one more example is given, that work and heat. If different paths are chosen to reach from one point to another and the work done will be different, however, you reach the same in each case. So work is not a state function, and we cannot say that a system will have a specific amount of work at a specific state. Now let's talk about some differences between state function and path functions. State functions like a kind of a property whose value do not depend on path. And when we are talking about path functions, this is like they are totally dependent on path to reach that particular value. State functions are also known as point functions, and path functions are also said to be process functions. State functions, in the state functions, what happened, like integrated using values of the initial and final state of a system. Here we are having multiple integrals and limits of integration for integrating the property of a system. Value of a state functions remains the same regardless of path or steps involved to reach that particular value. And here when we are talking on the other hand about path functions, so will be different if a different path is taken to reach that final state. Different paths gives the same value in the state function and different paths give different values in path function. So some of the examples of state function are entropy, mass, temperature, volume, Gibbs free energy. These are state functions which are acquiring initial and final states. And example of path function are heat and mechanical work. So I think that this video will be helpful to give you an idea about the differences between your state functions and path functions. And if you really like this video, so please do subscribe my channel, like and share. Thank you everyone.